Last video we talked about what is the reaction rate. Now we want to talk about the difference between instantaneous and initial rates, as well as an average rate and what the differences are. And so I've got the data from the previous video that we talked about here, and from there I'm just going to sketch this plot, and it's just going to be concentration versus time more generally. And if we draw this picture, something like that. And what we can see is that an average reaction rate takes 2 times and finds the slope of this line between those 2 times. And so this is going to be an average rate. And an instantaneous rate is going to look like take whatever spot you've got there and draw a tangent to the line. And while my line's not very straight, I do have a ruler, so I can try to do my best to draw a tangent right at that point. There we go. And the tangent gives the instantaneous rate. Instantaneous, one of my favorite words. It has tan in it. Don't know why that amazes me. Okay, so that's average versus instantaneous rate. And what we can do is then ask the question, so why do we care about initial rates? Well, first off, an initial rate is going to be drawing a tangent line at t equals 0. Which is technically impossible since it's the end of the line and tangents are always just touching the line as it occurs. Practically speaking, whenever we do an initial rate, it's always between the first 2 points here. So our initial rate would actually be an average rate, and if you want to get a better initial rate, you would take time closer to the beginning. So in most cases, we will approximate the initial rate as the average rate for our first 2 data points. So again, it's not perfect. It's an initial rate. It's the beginning. It's the best we can do. Now, why do we care about the initial rate? And why will we use the initial rate for doing a lot of our calculations coming up? Well, in theory, or in practice even, so in practice, and I guess in theory is what I should say. In theory, all reactions go both in the forward direction, and the reverse direction. And that's a major theme for the rest of the course, by the way. So all reactions go in both the forward and reverse directions. And that means at all times other than at the beginning of the reaction, at all times other than initially, product is present. And the rate of the reaction is affected by it. by the product. However, initially, there's only reactants present. And only forward reaction. I'm a little stuck here on Zoom. I'm not sure which direction looks like forward to you, but we'll just do forward and reverse. But initially, there's only forward, whichever direction that is. Initially, only reactants present. And so if we want to study the rate of the forward reaction, we need to do it initially. Initially, only reactants present and only forward reaction. It basically keeps it nice and clean so that we're only thinking about one of the reactions. Now, in principle and in theory, that we will typically look at reactions that are much faster going forward than going backwards, and so it's a way of keeping it neat and clean. But typically, the reaction rate is much faster in the forward direction at what we're going to be looking at anyway. So that's why we'll care about initial rates. This next page is a companion problem, and it gives you practice calculating initial and average rates. And we'll stop there.